All right, so here we go. Remember, I talked about in our video for today's lesson that the most important you should be asking yourself is where is the vertex of our angle? Okay, and number one, the vertex of our angle here is on the circle. Since it's on the circle, I take the arc that it forms. So it looks like it forms BC. It eats BC, so I do 84 and divide that by 2 to get 42. Okay, same thing here. Angle G, vertex is on the circle. The arc that it eats is this whole thing here. Okay, well, I know that this is 120 and this is 70. Remember that a circle has to add up to 360 degrees. So 360 minus 120 gives me 240. 240 minus 70 gives me what? How am I not getting this? 170. 170. All right, my vertex is on the circle. Angle G, like I said, angle G eats this whole thing. So I need to do 170 with the vertex on the circle. I divide by 2, and that's where you get 85. Okay, find the measure of the red arc or angle. So here's our red arc, E, H, F. Good thing I always mark it red, right? So that angle eats this arc, EF. Okay, but we're given this other angle with the vertex on the circle. If we look at angle G, whoa, the vertex is on the circle. If I follow it out, it eats the exact same arc. It eats that green arc. Okay, it's funny you should say that. So that makes this green arc 51 times 2, or 102. And then to get angle H, I do 102 divided by 2, or EFH, to get 51. Notice that these are the same. These are going to be congruent because they intercept the same arc. Okay? Now, find the measure of the red arc. Okay? So this is here to confuse us. Here's our red arc right here. I'm going to follow the angles back to intercept that arc. I know that that angle intercepts it, and I know that this angle here intercepts it. Well, that 45 is there to confuse us. That 45 applies to this angle here. So that doesn't help us. The only angle that helps us is this 40-degree angle down there. All right, to go from arc to angle, I divided by 2. Now I'm going from angle to arc. So I'm going to take 40 and multiply it by 2 to get 80. Biggest thing is just following the intercepted arcs. Next one, here we go. Describe the error. Well, the angle A, the vertex is on the circle. Follow it out. That means this arc must be 2 times that. Okay, it's not going to be congruent. It's only congruent if it's a central angle. So it was not doubled. Therefore, BC is 106. All right, got to double the angle. Use the tangent line T of the circle to find AB. All right, so here we go. AB, BAT. Here's my angle. The arc that it intercepts is right here. The angle that I'm given is 65 degrees. To go from angle to arc, I double it. So 65 times 2 gives me 130. 130. Keep going. We're flying today. We are flying today. Okay. I don't know what that was. Don't ask. Okay. I think it was my neighbor. All right, so here's my angle X. The vertex is not on the circle, it's inside of it, okay? It's floating. I have an X, and it's inside the circle. I follow it out this way, but I also follow it backwards as well, remember. Okay, so that means I'm looking at these 2 arcs there. Okay, when it's inside the circle, I do A plus B divided by 2. So I'm going to do 85 plus 145, and then all over 2, and that'll give me X. And you should get 115. Okay, I believe that comes out to 230. Okay, then you get 115. All right, so here the vertex was inside the circle, and this one, our vertex is on the outside. Since it's on the outside, remember I follow the angle the angle out again. All right, this is a hungry arc. Okay, hungry angle. So remember, for holy buckets. When angles are on the outside of the circle, the vertex is on the outside. I do the farther arc, which in this case is 114. minus the closer arc, which is x, divided by 2 gives me the angle. Well, to solve for x here, I'm going to multiply both sides by 2. Now I got 114 minus x equals 58. And then you can do a couple different things. You can subtract 114 and then divide by -1. I could subtract 58 and then add x. Either way, you should get 56. But the hardest part here is knowing the setup. When it's outside, I subtract. When it's inside, I add. I think about this x here as being like a big addition symbol. Okay, so this is something we talked about at the end of our second video yesterday. All right, that if I have a tangent angle, so look, this is a tangent line and a tangent line. Okay, a tangent angle means that this angle and arc B, the closest arc, are going to be supplementary. So I can do 6x minus 11 plus 125, and if they're supplementary, that means their sum is going to be 180 degrees. Okay, so 6x plus, if I combine my like terms here, okay, that's what, 114? All right, so 6x equals minus 180, 80 minus 70, 66. So x is 11. Which, oh look, x is 11. How fun. We are cruising today. It's a quick video. Describe the error. Okay, well look, the vertex of this angle is inside the circle. Okay, if it's inside the circle, that should automatically tell you that it's not congruent. Right? It's saying that it's not a central angle. All right. How do I know it's not a central angle? Well, because here is the center of your circle. Okay. If that's the center of my circle, then this is obviously not a central angle. This vertex is inside the circle. So what would I do? I know I didn't ask for this, but what would I do to find it, to solve this angle? Since it's inside, I would add my two arcs and divide by 2. Oh, I did ask you to do that. To find the correct measure, all right, you should get 41.5. You know, you have to read the question fully, Cholo, which is something I didn't do, okay? I described the error analysis. So this, holy buckets, this was, they started correctly, all right? The vertex is outside the circle. I do the farther arc minus the closer arc, but the person forgot to divide by 2 or multiply by 1/2. All right, if the last step is to do 122 minus 70 and then divide that by 2. Okay, so once you divide that by 2, then you get that. Then you get 26. All right, those are the practice problems for today. Hope that helped. Let me know if you have any questions. Reach out to me. I'll be on office hours. I'll be all over Google and stuff, all over my email. Have a good day.